Hello guys, this is the part 1 video of our summarized electrical engineering course. And at the end of each topic, we'll try to solve a sample problem. So our first topic is about basic electricity principles. Coulomb is a unit of electric charge and it's equivalent to 6.24 times 10 to the 18 of electrons or protons. Electric charge is equal to the current flow with respect to time. So the formula is Q is equal to I multiplied by T, where Q is the electric charge measured in Coulomb, I is the current measured in amperes, T is the time period measured in seconds. Potential difference. Potential is the capability of doing work. Any charge has the capability of doing work of moving another charge either by attraction or repulsion. Volt is the unit of potential difference, which is equal to 1 joule of work done in every 1 coulomb of charge. Electric current is when a potential difference between two charges forces a third charge to move. The charge in motion is called the electric current. Ampere is the unit of charge flow equal to 1 coulomb of charge past a given point in 1 second. We can also refer to the formula of Q is equal to I times T. Next, for our sample problem, a cloud of 5 times 10 to the 19 electrons move past a given point in every 4 seconds. How much is the intensity of the electron flow? We remember our formula. Q is equal to I times T. We need first to find the electric charge given the 5 times 10 to the 19. So our Q will be 5 times 10 to the 19. So 1 coulomb is equal to 6.25 times 10 to the 18. So our Q will be 8. So this problem is looking for the intensity of the electron flow, which is the I. So our current will be charge over time. So charge is 8 and time is 4. So our electron flow is 2 amps. Resistance. Resistance is a measure of the opposition to current flow in an electrical circuit, and it's measured in ohms. Resistance is equal to the resistivity times the length of the material all over the cross-sectional area. Also, resistance is equal to the resistivity times the volume of the material all over the square of the cross-sectional area. Also, resistance is equal to the resistivity times the squared length all over the volume, wherein the unit of the resistance is ohms, cross-sectional area is m squared, resistivity is ohm meter, length is meter, volume is cubic meter. Let's try solving this sample problem. The substation bus bar is made up of 2 inches round copper bars, 20 feet long. What is the resistance of each bar if the resistivity is 1.724 times 10 to the negative 6 ohm centimeter? This is the round bus bar and the length is 20 feet long. The diameter is 2 inches. Now we use the formula R is equal to the resistivity times the length all over the area. Next, we find the cross-sectional area of the bus bar. So area of a circle is equal to pi d squared all over 4. Now let's substitute. So pi is equivalent to 3.1416. Then for the d, the diameter is 2 inches. Now we convert this into centimeter. So 1 inch is equal to 2.54 centimeter. Now our area is 20.26 centimeters squared. Since the unit of our resistivity is ohm centimeter, we convert all our other units to centimeter. So our length is 20 feet. We convert this into centimeter. So 1 foot is equal to 12 inches. Then 1 inch is equal to 2.54 centimeter. So feet will cancel and also the inches. Now our length is 609.6 centimeter. Now let's substitute our values to the formula. R is equal to resistivity times the length all over the area. So our resistivity is 1.724 times 10 to the negative 6 multiplied by the length, which is 609.6 centimeter all over the area. So our area is 20.26. The resistance is equal to 5.185 times 10 to the negative 5 ohm. Circular mil or cm. It is the area of a circle having a diameter of 1 mil. Please take note of the unit conversion of 1000 mil is equal to 1 inch. 1 mcm is equal to 1000 cm. Our formula cm is equal to d squared. Let's try solving this sample problem. A 250 mcm ACSR cable has 39 strands. Determine the diameter in mils of each strand. First, let's convert 250 mcm to cm. So this is equal to 250,000 cm. Then now let's get the area of each strand. So to get the area, 250,000 divided by 39. So area for each strand is 6,410.24 cm. The problem is to find the diameter of each strand. Our formula cm is equal to d squared. So d is equal to square root of cm. So let's substitute. 6,410.25. Our diameter in mils is 80.06 mils. Effects of temperature in resistance. Most wires used in electrical systems increases its resistance as temperature increases. Please take note of the formulas. R1 over R2 is equal to absolute temperature plus the initial temperature all over the absolute temperature plus the final temperature. Final resistance over initial resistance is equal to 1 plus the temperature coefficient of resistance multiplied by the change in temperature. Also, the temperature coefficient is equal to 1 over the absolute temperature plus the initial temperature. Also, change in temperature is equal to final temperature minus the initial temperature. Temperature coefficient of resistance, or alpha, is equal to the ohmic change per degree per ohm at a specific temperature. For this problem, the field windings of a series motor has a resistance of 120 ohms at 15 degrees C. After running for 2 hours, the resistance increases to 140 ohms. If the temperature coefficient of the windings at 0 degrees is 0.004, find the new temperature of the windings. First, let's find the absolute temperature. So we use this formula. We need to find the temperature coefficient, which is the T. So let's substitute P plus T1 equals to 1 over alpha. So T is equals to 1 over alpha minus T1. Our T1 here is 0 and our temperature coefficient is 0.04. Let's substitute. T is equals to 1 over 0.004. Let's simplify. T is equals to 250 degrees C. To find the new temperature, or T2, our formula is R2 over R1 is equals to the absolute temperature plus T2 over absolute temperature plus T1. T2 is equals to T plus T1 times R2 all over R1 minus T. Okay, let's simplify. Our T is 250 plus T1. Our T1 is 15 degrees C. Our R2 is 140 ohms. All over R1. R1 is 120 ohms. Minus T 250. Our T2, or final temperature, is 59.2 degrees C. Another problem, two heating elements, which is 600 ohms and 300 ohms, are connected in series with temperature coefficient of 0.001 and 0.003 ohms per degree C, respectively at 20 degrees C. Calculate the effective temperature coefficient of the combination. First, we need to find the final resistance with each heating element given the initial resistance and the temperature coefficient. We're going to use this formula. R2 over R1 equals to 1 plus alpha delta T. So, final resistance is R2 equals to R1 multiplied by 1 plus alpha delta T. For the first heating element, R2 is equals to 600 times 1 plus the temperature coefficient is 0.001 delta T. For the second heating element, the R2 is 300 1 plus 0.003 delta T. Since the two heating element is connected in series, we have to add the two final resistance. So R total is equals to 600 1 plus 0.001 delta T plus 300 1 plus 0.003 delta T. This will be our equation 1. Also, our total is equals to 600 plus 300 1 plus alpha delta T. This will be our equation number 2. Now let's equate equation 1 and equation 2. This is equal to 900. Okay, let's simplify. 600 plus 0.6 delta T plus 300 plus 0.9 delta T is equal to 900 plus 900 alpha delta T. So this one will cancel. 0.6 plus 0.9 is 1.5 delta T equals to 900 alpha delta T. So our alpha or temperature coefficient is 0.00167. Insulation resistance of cables. Insulation resistance of a cable is a resistance offered by a cable to avoid leakage current that is harmful to human and to the equipment. Please take note of the formula. Rho is the resistivity of the insulating material. L is the length of the cable. R1 is the radius of the cable. R2 is the radius of the outer surface of the insulation. For this problem, a cylindrical rubber insulated cable has a diameter of 0.2 inch and insulation thickness of 0.3 inch. If the specific resistance of the rubber is 10 to the 14 ohm centimeter, determine the insulation resistance per 1000 feet length of the cable. Let's draw first the insulated cable. This is the radius of the cable. This is our R1 and the radius of the insulation. This is our R2. So our R1 is 0.1 inch because it says the diameter is 0.2 inch. For our R2, it says that the thickness of the insulation is 0.3 inch. So to get the R2, 0.1 plus 0.3, which is 0.4 inch. Our formula for the insulation resistance is R is equal to rho over 2 pi L times ln of R2 over R1. Okay, let's substitute. Our specific resistance of the rubber is 1 times 10 to the 14 all over 2 pi times the length, which is 1000 feet. Okay, so 100 centimeter is equal to 3.28 feet. Then ln of 0.4 over 0.1. If you notice, I did not convert this one to centimeter because we are looking for the natural logarithm. So the value will be the same. Then let's simplify. So our insulation resistance is 720.39 mega ohms. Another problem, the insulation resistance of a kilometer of the cable having a diameter of 2 cm and an insulation thickness of 2 cm is 700 ohms. If the thickness of the insulation is increased to 3 cm, find the insulation resistance of the cable. Okay, so let's draw first the cable. This is our R1 and this is our R2. Our R1 is 1 cm and R2 is 3 cm. The thickness of the insulation cable is 2 cm. So R2 is 2 cm plus 1 cm, which is 3 cm. And it says that the insulation resistance is 700 ohms. So the problem is find the insulation resistance of the cable if the thickness of the insulation is increased to 3 centimeter. This is our formula for the insulation resistance. So to find the new insulation resistance, we can use the ratio and proportion. So R1 over R2, which is the final insulation resistance. Then ln of R2 over R1 over ln R2 over R1. You may notice that I did not include this one because we're talking about the same cable, so this one will be cancelled. So this will be our formula to find the new insulation resistance of the cable. Then let's draw the cable with the new insulation thickness. This is the R1. This is R2. R1 will still be 1 centimeter. And the new insulation thickness is 3 centimeter. So our R2 is 3 centimeter plus 1 centimeter, 4 centimeter. Okay, let's substitute. So our R1 is 700. Our R2 is 4 centimeter over R1 is 1 centimeter. Then our R2 is 3 centimeter over 1 centimeter. So our new insulation resistance of cable is 886.23 ohms. Conductance. Conductance is a measure of material's ability to conduct. It is also the reciprocal of resistance. Conductance is equal to 1 over R. Conductance is equal to delta times A all over L. Conductivity is equal to 1 over rho. This is our sample problem. The resistance of 150 meters of wire is 16 ohms. What is its conductance? So the formula for conductance is the reciprocal of resistance, or 1 over R. So R is 16 ohms. So our conductance is 0.0625 and the unit is mho. Okay, so that's it guys for our part 1 video of the summarized electrical engineering course. Please subscribe to my channel and hit the notification bell to stay updated in my next video.